who have taken intro to engineering or took it last year or whatever are kind of a little familiar with this. We did the rudimentary version of this. So the trapezoidal rule, it's another way of kind of estimating. So we had the LRAM, the RRAM, and the MRAM. Trapezoidal rule is one of these again. So if I had a more curvier than that, so it's easier to draw the trapezoids. So if I had something look like this, and I'm going from here to here, A to B, right? I'm going to go from here to here. I can go equal, now I'm going to go in equal partitions, equal length partitions. And if I go like this, what I'm going to do is so this would be A, and the book calls this X1. This is X1. So we're going to add from here to here is going to be X1, I'm assuming. We're just going to call it H. We'll just call it H. So we're going to call this H. So from here, we're going to call this guy H. All right, so we're going to use the trapezoidal rule. We're going to go like this and say we're going to do a trapezoid and say we're going to call that the estimate of the area under the curve. Instead of doing the LRAM or the MRAM or the RRAM, we're going to do a trapezoid, okay? So we're going to continue to do the same equal length H's right here. So each one we're going to go ahead and draw a trapezoid. So as you can see, some of these are going to be an underestimate. This is going to be an underestimate. This guy here will be an overestimate. This guy here will be an overestimate. We're going to hope those will kind of even out, right? So we're going to have to calculate each one of these. We're going to calculate the area underneath we're going to calculate the trapezoid and call that the area under the curve, okay? So we're going to call this, we'll call this Y0, Y1, Y2, Y3, Y4, well, so these are all H increments, right? And we'll call this guy Y0, we'll call this guy Y1, Y2, Y3, Y4, we'll call this guy Y5, okay? So the area of the trapezoid here is going to be what? Y0 plus Y1 divided by 2 times H, correct? That was number 1 right here, right? That was number 1. And then we'll do number 2. Number 2 is this guy right here. That's going to be Y1 and Y2. So it's going to be H Y1 plus Y2 over 2. Then we're going to do 3, which is going to be right here. We're going to have Y2 on one side and Y3 on the other side. Y2 plus Y3 over 2. 4 is the same way, it's going to be Y3 plus Y4 over 2. 5 is going to be Y4 plus Y5 over 2. So interesting thing happens here. If I'm going to add 1 through 5, we're going to have to add 1, 2, 3, 4, 5, and add them all up to get the area underneath the curve, right? So if I add them up, I have, let's make this a little easier for you to look at. So I'm going to go ahead and pull the 2s, 1/2 over here. I'm going to pull it out. So I'm going to get rid of these right here. Now I'm adding these all together, right? I'm adding these all together, so I'm going to add all these together. So I'm going to add 1 Y0, 2 Y1s, 2 Y2s, 2 Y3s, 2 Y4s, and 1 Y5. In other words, the end boundaries get added once, everybody else gets added twice. Okay? So if I add them all together, what I'm going to end up with is I'm going to end up with something that looks like h over 2, and I'm going to get y1 plus 2y1s, 2y3 2s, plus 2y3s, 2y4s, plus y5. Okay, so this is the trapezoidal rule, okay? The area underneath is going to be the area underneath the curve is going to look like this. 2h over 2, y0 plus 2y1, 2y2, 2y3, 2y4. So this works best if you have, well, actually it works really nice if you have a data, right? If you have data, you just plug in the data, okay? All right. But also an interesting thing happens here is that if I were to go back and if I were to just use the LRAM, what would I have gotten? The LRAM would have been what? H times y0 plus y1, y2 plus y3 plus y4. This would have been the LRAM, okay? This is the LRAM, okay? The RRAM would have been what? RM would have been H, and we're going to start with Y1. We're going to start from the right-hand side first, right? Y2, Y3, Y4 plus Y5. That's a 5. Y5. Okay. What happens if I add these two together? If I add these two together, I'm going to get what? I'm going to get, so I'm going to add this guy plus this guy, right? So it'll be H, Y0 plus 2y1, 2y2, 2y3, 2y4 plus y5. Doesn't it look exactly like this? Except for I'm dividing by 2. So this is going to be LRAM plus RRAM. Is going to be that guy, right? This guy right here. But if I divide it by 2, I'm going to divide this guy by 2, which ends up being what? Right here. So the trapezoidal rule is basically adding the LRAM plus the RM and dividing it by 2. Okay, and this holds true for any shape, whether it's continuously decreasing or increasing, it doesn't matter. Okay? So if you go to page 315, there's a green box there where it shows the trapezoidal rule. To approximate the integral from a to b f of x dx, we use, and then we have this guy here, right? T is equal to y0 plus 2y1, 2y2, all the way through till the very end, 1, which is going to be y5 here for us. It would have been yn for the book. That's equivalent to adding these two and dividing by 2, adding these two and then dividing it by 2. Okay? So to apply that rule, see if we can do that. Let's see if we can use example number 1 and see if we can actually do this. Example number 1. We have used the trapezoidal rule with n equals 4 to estimate that. Compare the estimate with the exact value. Okay, so we have 1 to 2 x squared d of x. One, 2, and we're doing 4. Right? 4, so each one of these, the width's going to be what? 2 minus 1 divided by 4, right? Which is going to be 0.25. So it's going to be 0.25. That will be our h. But we're dividing it by 2 because we're using the trapezoidal rule. And we're going to go this guy here first. 1 plus 2. The next one right here, 2 of those, right? That would be 1.25 squared, but this is 1.25. This is 1.5, 1.75, right? 2, 1.5 squared. Well, not squared. Yeah, squared, because we're looking at x squareds here, right? Okay, plus 2, 1.75 squared. And then we're going to have the very end one, which is going to be 4. 2 squared is 4, right? Okay, that's how you would do that. And if you do all that, you're going to end up with 2.34 4375. Is that what? 2.34375. Okay, and we want to compare this with the nth value. Somebody do the nth for me. What do you get when you do the nth? So the trapezoid rule gave us 2.34375. Okay. What did the nth give us? Anybody? Logan, do the nth.
What?
Do the nth. Do the calculator.
I'm sorry, I can't hear you. It's cutting out.
Do this using your calculator.
Okay.
While you're doing that, I'm going to do it exactly, right? So exactly, we have to find the antiderivative of this. What is the antiderivative of this? 1/3 x cubed from 1 to 2. So it's going to be 1/3 8 minus 1/3 times 1, right? 1/3 7, which is going to be 2.333333. So the algebraic gives me 2.3 repeating. What does the nth give us? Logan?
What?
What did your calculator say it was?
I'm trying to figure it out.
Caden, what does your calculator say? Luke, what does your calculator say? Nobody have a calculator out of the 3 people I called off? I'm doing pretty good here. Eva, what does your calculator say?
2.33333.
2.3333. So the nth gave us 2.33333 also. Okay? You think about it, you're not that far off, right? So the trapezoidal rule, we only did 4 increments, four strips, right? Which is pretty rudimentary if you think about it. And we're still pretty darn close to 2.33333 there, okay? So it just goes to show you how, close the trapezoidal rule actually is. Caden, Logan, and Luke, you guys need to know how to figure this out. Okay, let's do example number 2. Example number 2, again, is the data points, right? The data point, right? So you have an observer measures the outside temperature every hour from noon until midnight, according to the temperatures of the following table. Okay, so you have what? What is your H here? Can anybody tell me what the H is?
Is it 1 hour?
H is 1 hour, correct? Because it's 1 hour increments. Each of them have 1 hour increments. So your temperature is going to be we're looking for the average temperature, right? So the average temperature is going to be H divided by 2, right? And it's going to be y naught plus 2y1 plus all the way through till 2y11 plus y12. So the H is going to be 1 hour divided by 2. And what is your y naught here? What is y0? 63, right? The next one is 65. The next one is 66. And we go all the way through 2 times 58. The very end one was 55. right? And this is what you would do. The data is just plug and chug it right in, right? Go ahead and do that and you will find out something, right? We get 782. 782. Okay. And so you're gonna have to do what? You have to divide this by 12 hours, right? So you said this was gonna be 782. 782 divided by 12, because that's in a 12-hour period. Looking at 65.17. Okay. And we'll stop right here for the first part, and then we'll continue with another one.